Hey guys, this is Mr. Themes here again, coming to you with another guided notes lesson. Today's lesson is lesson 11-2. Make sure anything I write down on the screen, you write down on your paper. Let's mark up these learning targets here today. Today we're going to be finding the rate of change from a table, and we're also going to be identifying linear and nonlinear functions. So this first real world situation here, let's imagine you go to the High Ratio Mountain ski resort and you buy a 10-day package for ski lift tickets. A lift is what takes you up the mountain so you can ski down the mountain. This 10-day package is $80 upon the purchase, and then it's $20 per day after that. So $20 per day, each day, every day. So at the start, before you can even get on the ski lift, you have to pay $80 upon the purchase, so $80 up front. So after 0 days, it's $80, and then every day after that, it's an extra $20. So after day 1, it's $100, day 2, it's $120, day 3, $140, day 4, $160, day 5, $180, and after 6 days, that's $200. So we went from this real world rate of change, $20 per day after $8 purchase. We put it on the table. Now let's graph it on the line. So after 0 days, it's going to start at 80. Put a point here. 1 day, 100. 2 days, 120. 3 days, 140. And notice this graph goes up real nice for us already. Go ahead and put your points there. And then let's connect all these points and make it draw a straight line. So it starts at 80 and it goes up from there. And it should form a straight line. This straight line is what we call a linear equation. It goes up and it has a constant rate of change. Since every day is $20, it has a constant rate of change. And the slope of this, in this case, would be $20 per day, each day, every day. Let's look at these 4 tables and let's find the rate of change on these tables. Rate of change is just another way to say slope. So what I want you to write somewhere on your paper is I want you to write that the rate of change or the slope is the change, and this symbol stands for change, in the y over the change in the x. Change in y over the change in the x. Okay, so let's look at the change in, let's do the change in the y first. Notice it goes from 1 to 7. That's an increase of plus 6. It goes from 7 to 13. That's also an increase of plus 6. And the x values, it goes from 0 to 3 and 3 to 6. So that's both of them are a change of 3. So then our slope would be 6 over 3. But we need to always reduce this down. This reduces to 3 over whoops, hold on, not 3 over 1. This reduces to, 3 goes into both, so it reduces to 2 over 1, or finally it has a slope of 2. So circle that final answer there. This has a slope of 2 total. That would be the slope of that first one. I'll look at another one with you. So this change in the y over the change in the x, it goes from 10 to 4. That's a decrease of 6. From 4 to negative 4, that's a decrease of 8. This one is an increase of 3, so plus 3 from negative 3 to 0, and then from 0 to 4, that's an increase of 4. So this one does not have a slope because it's nonlinear. This is nonlinear. It's not a constant rate of change. So this one is actually nonlinear because they are not the same. The pattern is not the same in this table. So this is a nonlinear rate of change. I want you to press pause, and I want you to do the next 2 on your own and see if you can find the rate of change for this table and this table. Press pause and do that on your own. Okay, flip your paper over to the back side now. On the back side, you'll notice 2 real-world graphs that are both similar, but they both have different numbers in them here. So we're going to find the rate of change of this real world situation. What I want you to notice on this is that The days would be your x term or your input, and this is going to be your output. So it's still, to find the rate of change, is still the change in the y over the change in the x. Okay, change in y over change in x. So the change in the y, 500 to 490, water measurement. So the water seems to be going down here. It's going down by 10 each time. Minus 10, minus 10, minus 10, minus 10. Each one is minus 10. So it's a constant rate of change going down in the y. And notice each one of these days is plus 1, plus 1. Every day is plus 1. So we do have a constant rate of change, so it is linear. And then what it ends up being is the water measurement is going down negative 10 per 1 day. So this is 10 milliliters, ml, per 1 day. Make sure you label this. I got milliliters from here, and I got days from here. It's really the water measurement in milliliters per day. So the rate of change of this is going down by 10 milliliters per day. Press pause and do 1B on your own. Okay, now we're going to look at these tables below, and we're going to identify the slope, and we're going to talk about if it's linear or nonlinear. So first, finding the change in the y first is going plus 2 here. Oh, now it goes plus 4, and then it goes plus 8. This one goes, x terms go plus 2, plus 2, plus 2. So the x terms are constant, but the y terms are not. So this is a nonlinear, and it does not have a slope at all. Nonlinear and does not have a slope at all. Press pause and try 2B on your own. For 3A, let's find the rate of change on these. So notice that now we have negative 2 to 4 to 18. That's a decrease of negative 16. Whoa, 50 to 80. Let me do that math real quick. Minus 8 to 18. What's that difference? That difference is borrow 2, 4, so 32. That's a decrease of 32. This one looks like it's also going to be nonlinear as well. So this one's going to be nonlinear from negative 50 to 190. Man, let's see. Do that work again. We get 48. So this is going down by 48. So that's nonlinear. These go up by plus 2 every time, but since this is not a constant rate of change, then we know that this answer is going to be nonlinear, and again, it does not have a slope. Since these are both nonlinear, I want to go back to 2B just to check your work on 2B, see if you got the right answer for 2B. So the rate of change on 2B is going down by 3. From 3 to 0 is negative 3. From 0 to negative 3, that's also negative 3. And from negative 3 to negative 6 is a difference of negative 3. So that's constant there. This one, the x terms are going up by plus 4 each time. 12 to 16 is plus 4. So this is linear. Circle that. And then our slope is going to be, let's see, change in y is negative 3 over 4. That's our slope. So the 2a is nonlinear, 2b is linear, slope of negative 3 over 4. 3a is nonlinear. I want to try 3b now. Actually, I want you to try 3b. Press pause and try 3b on your own. All right, I'll do 4a. So 4a, let's find the rate of change here. 12 to 10, that's going down by 2. 10 to 8, that's going down by 2. 8 to 6, going down by 2. Though our y terms are going down by 2. All of our x rate of change looks to be plus 3 on each one of these. Notice a pattern here. Okay, so this is linear. It's a linear function because it's a constant rate of change for both the x and the y. And our slope would be the change in the y, which is negative 2 over 3. Negative 2 over 3. Press pause and try all the rest of these that you haven't already done in numbers 2, 3, and 4. Okay, moving to this bottom, I'm going to do the first two. So I'm going to do these first two, and all we're doing here is identifying the linear, whether or not they're linear or nonlinear. So again, linear means a straight line. So this first one here, that's a straight line right there. So then that means that this is linear. So write linear on this line. The second one here, this is a curved line. This function is actually a curved function. The graph is curved. Whenever it's not a straight line, that means it's nonlinear. The word linear means straight line with a constant rate of change. You guys should be able to do these last three on your own. When you get done with this, you're going to work on your IXL assignment. So finish this and you're done. Good job.